Let me tell you a story before we get started. The story is actually even cooler now because one of the main protagonists of that story is in this room with us. So, I had the privilege of being at this conference, VIScon, since actually the beginning, VIScon 2018, I apologize. Every year, except for 2022, where we were logistically challenged to be here, but so happy to be back. I heard I still have the record holder of being the speaker that has been here the most, so glad to continue that tradition. So, the reason why the story is quite interesting is the reason why we're here. This wasn't really planned. This was more, I mean, it's planned now, but the idea, the inspiration came from you, the students, the participants of this. And I don't mean this in like a corporate setting, like, yeah, you inspire us. Like, you do that too, of course, but this is quite a literal sense. So, our story starts in 2021, the last time I was here. I was here in, I believe, the room next to this one, and I brought this dog. Called Spot, Boston Dynamics Spot. And the idea here was, and it worked quite well, I think, is you wear the HoloLens and throw a virtual ball, and then the dog, the robot, would go fetch it. It would run there, the real dog, it would pick up the virtual ball, and then bring it back to you, as you can see here. So that worked quite well. And I had a really cool assistant, which you can see back here, who was helping me because I'm not really a roboticist, so I needed someone who knows how to tame this animal to help me out with this. So that worked quite nicely. Unplanned, but somewhat expected. After this talk, there was lots of interest, of course, in Microsoft and in the dog itself. So I went outside, somewhat on my way home, but, well, the dog was there. Lots of people wanted to actually see it. I heard the room was also blocked in because too many people wanted to enter. Yeah, everyone's wearing a mask, remember that. Yeah, so a crowd started to form naturally. People wanted to talk to me, wanted to see the dog, wanted to take pictures of the dog. It is quite cool. I showed you the dog, but what you didn't see on the video is I was wearing a HoloLens, because that's how I recorded this. Quick show of hands, who has heard of the HoloLens before? Oh my god, I love it. So I asked this question since 2018, and in 2018 when I asked this, like half the room were not even raised their hands. So now we almost have a full room, that's cool. Who has worn a HoloLens before? All right, about 30%. Hi, good morning. Yeah, no worries. We just started. You're missing the cool part, but okay. So people were naturally also interested in the HoloLens as well, not just the dog. Unfortunately, my assistant back then had to run, so it was just me with the dog and a lot of people. And additionally, there were people, hey, I want to try out the HoloLens, but I couldn't just let the dog run on its own. Someone had to actually take care of it. So fortunately, there was this random woman. I'm kidding, it's not a random woman, she's a friend of mine, and she's actually sitting here in the crowd. And she asked me if she can take the spare HoloLenses and just show it to people. So I know her, and she's doing a great job when she demos HoloLens. She's done that before. And obviously, I had nothing against it. Quite the contrary, I was super happy someone could help me out. So then this happened, and God bless whoever sent me these pictures. That makes the story even cooler. So yeah, then more and more people started to form around her, to a point where the crowd that she drew was actually larger than the crowd that I had, which is nice, but also, okay, cool, she's doing a better job than what I'm supposed to be doing. The app that she showed, and that we usually show to people that haven't used the HoloLens before or the first time, because it can be quite overwhelming. HoloLens 2-second intro is just an augmented reality device, for those of you who haven't seen it. I can put it on my head, and I can see through it. So unlike these pass-through VRs that you're seeing a lot, which is becoming trendy nowadays with the Meta Quest, I believe, and the Apple Vision Pro, I think it's called. Also cool devices. One of the differences is I can see through my goggles here. The other one, you have a screen, and then it's just a camera that kind of projects through it. The application that we show here, that she showed, and that we usually show to people, is called the Graffiti app, Graffiti 3D. And this is done by my coworker Casey, published 2018 or something around this. Super simple app. I really love it because you don't have to understand anything, you can just use it. The way it works is you put up your hand flat in front of you, and you have this menu floating with your hand. It's just, you see a bunch of colors. And then you can draw, just in the air, just like that. Super simple. What I've found amazing is when people start drawing, because whenever we draw, we're very used to drawing in 2D, so they draw something in flat. What people aren't used to it is once they draw, they can actually walk around, and the hologram will stay there. And then they get a second wow effect, so, oh wow, even that works. There was one problem I had with this. It is not the next slide, I see. Very quickly, people were interested in this and started drawing, so the room actually looked like this. Again, thank you everyone who sent me these videos. So everything was full. You see me here in the midst of everything. I think I'm rebooting the dog because it was out of battery, so new battery. But yeah, you see all the millions, hundreds, dozens of holograms over here. For those watching this on YouTube, because I know this is going to be uploaded, you see a lot of this VMP. It's one of the student associations here. So naturally they wanted to leave their mark. That's why you have this logo a lot everywhere. So yeah, that was, I enjoyed seeing this after someone sent me this video. The problem I had with this is just, it was lacking one feature. It was, if you have two people, so we had two HoloLenses there, and if you have two people wearing a HoloLens, if the left person would draw something, the right person would actually not see it. So what I've seen people do is, they both wear the HoloLens, and then they draw something, and then they would actually switch HoloLenses just to see, hey, look what I've drawn. So I thought, what if we take that very simple idea, that Graffiti 3D application, and we add large room multi-user, it's great timing, and persistence over time. That's a beautiful word salad I put there. But basically what I want is to be able to share these holograms, and also the ability to just come back the next day and to still have it there, to basically persist the holograms. So that's what we're going to be talking about today. My name is Patrick. I thought that was my blurred out name. I'll quickly introduce myself, so for those of you who don't know me, I'm Patrick. I finished my master's here in 2017 at ETH in just general computer science. And around a month later, I started at Microsoft, and I've been there ever since. And in 2020, I joined the lab from Professor Mark Polyface. He's also a lecturer here. I've been a program manager since the beginning, technical program manager, which is basically if you're able to talk to customers, but you also understand what you're talking about. So that's been my job. So I enjoy presenting stuff to complicated stuff to non-technical people. I know in this room we actually have a lot of technical people, so that makes my job even easier, which is great. Okay, let's go back to our problem. We have people drawing, and they need to be able to see what the other person is drawing. Let's reduce the problem space to make this easy. Just make this a 2D application for once. So we have Alice and Bob. For some reason, computer scientists like these two people. Let's say we have a paint application. We've all used that. And let's say if Alice draws something, we want Bob to see the same thing. So more or less what we're trying to do, just a very simplified version. Conceptually, this is very easy. Why? Well, if Alice draws something over here, all she has to tell Bob is, hey, top left pixel, green. Bob knows exactly what to do. Same thing the other way around, of course. Makes sense. There's one core thing that this kind of concept has, and it's that we have a common coordinate system. Top left from Alice, Bob knows what top left means. 0, 0, 0, 1, whatever you call it. They both know where it is, so they're aligned on that. They don't even need to think about it. So that makes it a lot easier. Problem is, we're in augmented reality. Where's 0, 0, 0? It's quite difficult. We could say, hey, how about here's 0, 0, 0, and then our application somehow have to figure out, okay, where is here? So generally, it's quite difficult to do that. One way to tackle this, and this is a viable solution that I've seen before, is we use QR codes. So you have a QR code, you put it on the floor, we both stare at it, We kind of know, okay, this is our coordinate system, and then the left guy knows, okay, my hologram that I just draw, my line, my graffiti, is 2 meters up, 1 meter to the left. So the guy on the right can see that. So, okay, makes sense, because we have a common coordinate system. So all is good. There's two downsides to this, though, which I want to list out here. And first one is, you need a QR code. By show of hands, who packed in their QR codes this morning? Right. So I'm not saying this is a bad solution, because for some things, yeah, QR codes, they work well. It's a problem that has been solved quite a lot of times. QR code detectors aren't new, which is quite good. But yes, we need to adapt the environment, which is less optimal. And for your application, if you just want it to work, this might not always be the best way to go. By the way, this actually exists in the current Graffiti app, which is great, again, because I've talked to the guy, he's great, and it makes sense if you can prepare your environment. So that's one of the problems. The other problem is called the lever arm effect. I hope your phone is okay. Let me quickly show you what the lever arm effect is for those of you who heard this term for the first time. Lever arm effect happens when we start to go into distance. Let's use the QR code again for this example. We have a QR code here. We've aligned, okay, this is our coordinate system. I draw something 2 meters up, 1 meter to the left. You see it. Everything's well. What if I go 20 meters back here and I draw another thing? So this is starting to cause issues because now, I mean, I can still give you that information. It's instead of 2 meters up, 1 to the left, I'm now 2 meters up and 20 meters to the left. So there's two problems with this. One, QR code detections, they're not perfect. They're good, but they're not perfect. So even if we nail down this QR code, if both of us look at it, our algorithms might slightly offset this. So your QR code might be, your detected QR code might be just 1 or 2 degrees off compared to mine, because mine's also not perfect. This is not a problem if things are close, because a small rotation 1 meter away is just a small movement. From 20 meters away, that is obviously a much larger problem. So a lot of stuff breaking today. It's a Jenga, it's supposed to be. Okay, good, I'm happy. We're not in danger. There's the other thing which is also kind of problematic. If you're all the way back here, there's a chance that you're not seeing the QR code anymore. Or you see it very small, which makes the detection difficult. Now, devices nowadays, they're quite smart. Your phone, your HoloLens, if you look at something, you see the QR code, and then you look up, it still knows where the QR code was because it has internal sensors. It can use the camera, the accelerometer, the gyroscope, so it understands, okay, you've moved that far away. However, these sensors, they have some inaccuracies. So me walking, sorry, I'm this guy now. Me walking over here, I'm introducing and accumulating a lot of inaccuracies by the time I reach here. By the time you get back there, you have the same issues. You have other inaccuracies. So ideally, yes, we cancel each other out, but most likely we won't. So your graffiti, as the one you walk over here, is going to be at a different location. So we call this local tracking. When you've seen something, you look at the QR code, you have that tracking, but as soon as you walk away from it, you don't see it anymore. And then we rely on local tracking to make that work. So that's the lever arm effect. Let's see how we can solve this. I need to take a zip here. So, number one, we need a QR code. How can we get around this? Instead of having a QR code, nowadays we actually don't need QR codes anymore. It's just markers, as in we can also align on just any other image. I don't know, some cute little image of a cat or some pebbles or an actual cat. It doesn't really matter. As long as we both align beforehand, this is the image that we're going to use. We could use this cat here and just say, hey, the coordinate system is on the left eye. We both look at it. Same, it will work. So we don't need QR codes, but we haven't solved the problem. Now we all need to print cat images, which is also not better. There's something we can do on the fly. And here's an exercise I've started doing since, I think 2-3 years ago. So this is where the interaction comes in. Don't worry, you don't have to answer anything. This picture was taken in this room. Now, I want you all to point at where this camera was when this picture was taken. Right. So all of you are able to do that. Now I want you to think for a second why you were able to do that. This is very difficult for a computer, what you just did. Most likely, none of you have seen this except for the person who's sitting there. But everyone else probably hasn't seen this image. But still, you were able to look at your surroundings right now. You detected, oh wait, there's the table here. In your head, you were actually canceling out the people, probably. You recognize the ceiling, you recognize you recognize things, and then you were able to position yourself where this is. So computer vision can do that too. It's a lot more complicated, but still, it's able to do that. And we can do that on the fly. In terms, we don't have to print anything before. We can, as I run my application, just like I'm doing this presentation now, I just showed you this image on the run. And if I tell you now, hey, I've put an anchor right here on this desk, well, maybe let's use that speaker, it's easier. All of you would know where that is. So that makes it easier. So instead of having cool cat pictures, we just use the surroundings. You don't have to bring your own table, obviously, but we can use that and just say, okay, the anchor is here. So that works. And then, same thing, we define an anchor. We call these anchors, by the way, they're spatial anchors or visual anchors, cloud anchors, however you want to call them. After that, it's the same idea. We put an anchor here, we say 1 meter up, 1 meter to the left, and we have a common reference frame again. So we solved, in quotes, the QR code problem. We don't need to bring QR codes anymore, we just use the surroundings. How are we doing on time? Decently. Okay, so QR codes we solve by using anchors. What about the lever arm effect? That seems to, we still have that same issue, because even if we use this table, create an anchor, this guy tells this guy, hey, my hologram is 1 meter up, 1 meter to the left. If I go all the way back here, same issue. Just because the anchor is not a cat image anymore, yeah, it doesn't really help much. We still have the same issue with lever arm effect. So how do we solve this? Yes, you have an answer. Cool, tell me.
Can we use that person as an anchor, maybe?
Ah, cool. Just to repeat for everyone, he asked if we can use that person as an anchor. Kind of cool. So, short answer, yes. A bit longer answer. So you're going into the direction of object detection. So I'm objectifying you now. You're an object. If you're scanned in, we could use you as an object that can be detected. There's a bunch of issues, though. You're moving usually because you're alive, fortunately. And if you would be always standing like this, we can scan you in like this and then detect you like this. That works. The other issue with that approach would be this guy here can't scan himself. You would have to take the HoloLens and look at yourself quickly. So that's where this might start to break, which is why using anything alive as objects might be difficult, but cool idea. Yes?
What if you use multiple anchors?
Ah, nice. So just to repeat, what if we use multiple anchors? We don't have to print anything here. We're not like, oh, we can only print 2 QR codes and 2 cat pictures. No, this was basically for free. That table was here before. So, and I know my drawing is super realistic, but most of the time your room does not look like this. It's not a white room with just one table in the middle. Most of the time you have other materials. You have couches and more tables and plants and everything. So instead of just having one anchor, what if we just put anchors everywhere, like you said? Well done. When do you finish school? We can add an additional info now. Because if you think about it, right now we haven't solved the problem yet. Because this guy over here, yeah, he's going to draw something, and then attach, we can actually draw it here, and attach it to this anchor. This guy over here doesn't see that anchor over there yet, so that doesn't really help. It's actually, we got it worse, because this guy doesn't know where that anchor is. What we can do additionally, next to adding all these beautiful anchors here, is add the information as well, how they connect. Which means when I see this anchor, I can calculate the positions of all these anchors here, just translation of these two. of these three. And then we know where this one is. We still have the lever arm effect here. So this is not solution, because if I look at this anchor here and I do this whole calculation, it also has inaccuracies. But I know more or less where this is. If it's 1 meter off when I'm standing here, I don't care, it's fine. I know more or less where that part is. It's like when you have to go to, when you came to VIScon and you wanted to see this talk. When you leave your home, you're not going to think, I need to go to E1.1. You think first, okay, I need to get to ETH, so like just a rough area. You don't need to know the exact position point here. But then as you get closer, okay, where's E1.1? Okay, it's here. Okay, where's my seat? Okay, it's here. So you kind of narrow it down as you get closer. Same thing here. This guy, seeing this anchor, and knows more or less where this is. That's inaccurate, but doesn't matter. Now, if he starts walking, he'll see all these anchors along the way, and the lever arm gets shorter and shorter until he actually sees this one here. And at that point, we have a much shorter lever arm effect, where it shouldn't be a problem anymore. So, to solve QR codes, we use anchors. To solve the lever arm effect, we use more anchors. Just spread anchors everywhere. Decent with time. So, I'm going to show this to you live now. I don't know if you saw me and my coworker before we started. We were running around here. We placed anchors everywhere. That's right. You've all been sitting with anchors this whole time. How do you feel? So what I'm going to do is I'm going to show you these anchors. And the way I do this, I need to launch the application from my HoloLens. And I'm also able to, hopefully soon, there we go. All right, this is looking great. Yeah, this is always a bit of a challenge with the internet here. So, you see what I'm seeing now, plus the holograms? There is a 3-second delay, so if I put my hand here in the middle quickly, 2, 3, there you go. So this is always this is the most challenging part of my talk, is talking with delayed 3 seconds. So I have to do something and then only talk about it 3 seconds later. So I'm going to start the app, as you see. I'll try not to move too much so you don't get dizzy. And this is basically the app that you saw before. The main difference is we've re-implemented the app, so it's able to handle these anchors. And we had to remove some of the features because the other app is really, really good. And we had to tone it down. So you can only draw and delete. With the other app, you can still do many things more. Okay. So what I'm going to do is, I called it VIScon because, yes, the N and the M is very close to each other. I apologize to the conference. So I'm going to connect. Connecting just means it's going to look for any of these anchors here, which I hope they'll find soon. Again, there's always a bit of the question with the network here. So you don't know this yet, but I just got audio cue that it actually did find it. To show you, I can click on View Map. There we go. So you see these little cubes. Sorry, 3 seconds delay. You see cubes floating around. I don't have this the coordinate systems that you saw, but cubes, same thing. So anything that I would draw, so you see there's another one, sorry, 3 seconds, another one over here, and then we have 2 more all the way back over here. I don't know if you see them. There might be a slight dot on the screen. So these are my anchors. I place some, and there's, yeah, we have 5 or 6 in total. So anywhere I would draw in here, what I would do is I would just tell the cloud, the database, whichever, her HoloLens in a second, that, hey, I've used this anchor. They all have IDs. We gave them names. So I'll tell them, hey, I've used anchor called Susan, and the graffiti is going to be around that. So I will actually do that for you. There we go. I'm going to select the beautiful color, green and orange. Okay. So what my HoloLens is doing now is it automatically tells her, hey, this anchor, however we called it, has this graffiti around. And she hopefully sees it. Oh, that's beautiful. So instead of just taking my word for it, we're going to do this the other way around. So she's going to start drawing stuff. And every time she does, you're going to see stuff. So she drew this beautiful line, and she enhanced my previous circle. So this is beautiful. So this is how our HoloLenses now communicate with each other. So the drawing part, so let me try to stop moving and we can just stare at her while she draws. So the drawing part itself is independent of this thing, because she could just draw for herself, right, in her own little session, and she's happy, that's okay. But if we want to share these holograms with each other, it's important that her HoloLens and my HoloLens, and all the other HoloLenses actually, have aligned on these coordinate systems. So what her HoloLens is doing, every time she's releasing her finger, every time she's stopped drawing something, it will find what is the nearest anchor, because it's not going to anchor it to somewhere somewhere far away. Because again, liver arm effect, we want to keep that as to the minimum as possible. So every time she draws something, it'll find the nearest anchor, it'll find the name of that anchor, and then tell my HoloLens, hey, there's a graffiti here, there's these squares that she's drawing now. She's drawing the Microsoft logo for those who are not familiar with it. If you haven't figured it out by now, just to spoil it. So it'll tell my HoloLens, hey, there's a square here that's been drawn, the sausage. It'll tell me the exact coordinates of these sausages. And more importantly, it tells me, here's the nearest anchor and how far it is away and the rotation of it. And then, yeah, at the end of the day, we have a beautiful drawing. I'm going to look at it from the back. It's going to look exactly the same, just mirrored. But now the colors are correct, so Microsoft doesn't sue us for using their logo wrong. So that's basically it. For those of you who haven't tried it yet, we're in the exhibition. You can do this. You have drawn over 1,000 holograms so far, which is quite cool. You're really stress testing the system. It's fun. After this talk, the HoloLenses are now charging again. We've actually used all the batteries. We had 6 HoloLenses with us. We've used all of them. I absolutely love it. We're going to charge them again, and then I think we have another hour after this talk, so welcome to try it out. Okay, thank you for your attention. Happy to take some questions. Sorry, can you use I can also repeat the question, that's fine.
Hello. So the great talk, by the way. Is the latency only a problem for the streaming to us, or is the latency also between you two?
The latency, so there's the 3 seconds latency, as said, if I do the clap test again, yeah, around 3 seconds. So that's just the projection thing. The latency from her, it's, how do I explain this? So it's what you saw here is the actual latency. So when you see her drawing on the screen, and then the hologram popping up, that's the actual latency. Because what's happening is, yes, she's drawing, and just for bandwidth's sake, I'm not uploading every little pixel she does. So I'm only uploading it once she made one sausage. So she could make a super long sausage, and we would never know until she actually releases. As soon as she does release, there's 3 things that are happening, 4 actually. 1 is it finds the nearest anchor. 2, it uploads that information to the cloud, as in the graffiti information and the anchor information. And then the same thing in reverse on my HoloLens. It downloads it. It says, oh, there's a new graffiti over here. There's a new sausage. And it's close to this anchor. I know how to render it, and I know where that anchor is, so it's rendering it on my side. So all of this happens. The server is in Paris, I think, or in France somewhere. So that adds a bit of more latency. Usually for these demos, it's a good idea to actually use local storage, and things will go in quicker. But we thought it's easier to show. Well, first of all, show you the real thing, and this is a lot more portable. And also, if my laptop doesn't work, I assume Azure Microsoft Cloud will keep running. It's more stable than my laptop, which is why we chose the cloud for this one. It just requires less setup. Sorry, did I answer your question?
Yeah, and if you do the computation locally with a proper hardware, what's the latency I can get?
So the computation, there's not much computation involved, so a lot of things happen on the device. The only thing where the cloud is involved is the data transfer, basically. You could go peer-to-peer, of course, as well. That would probably be the quickest. The calculation itself is actually quite quick because our HoloLenses, you saw that, we saw the cubes, it knows where all the anchors are. It found them initially. So knowing where my nearest anchor is actually quite a quick call because I already know, where I am, and so that computation is quite quick. And then the rest is just normal data transfer. I can't give you an exact number, but it's less than a second, I would assume. Mm-hmm. Don't want to put my hand in the fire here, but I assume so. Yes?
So, like, you always need to have your hand in the HoloLens vision in order to be able to draw, right?
Let me put this down. Sorry?
You always need to have your hand in the HoloLens vision field to be able to draw. Or is it able to draw with, like, if you're walking around and you're not looking at your hand?
That's it's funny that you mentioned this. We actually had issues with this. So I'm sorry, I'm taking this HoloLens so you don't stop getting dizzy as I walk around. The HoloLens itself, sorry, I'm going to unplug it for a second. I'll plug it back in, I swear. The HoloLens, as I wear it, it has depth sensors up here. And the depth sensor is used to detect your hands. And the good thing, in some quotes, is it detects your hands down here as well, which is great because I can view stuff here, and almost like on a computer, I can do stuff here. I can grab holograms and everything like you saw before, but there's also, because my hands are being detected here, I could almost use this as a computer, so I don't actually have to look at my hands. So this sounds like a really good thing. For most of the things, it is. For this drawing stuff, that was one of the first feedback I received. Many people started drawing stuff here without them knowing. Because if I would just sit like this, I have my hands like this, and my HoloLens would think, oh, you have your hands like this, you're drawing stuff. So I would have on my keyboard and everywhere would lots of drawings, even though I didn't want to draw. So what I had to do is I actually had to reduce that field to just have it in front of you, because I noticed when people were using it, whenever you start drawing, very naturally people start drawing here. No one starts drawing down here. So I reduced the field actually to only be able to draw here. So to answer your question, yes, it's only in the field of view, but very intentionally only there. In theory, you could also draw somewhere else. What does work is you can start here in the field of view and then just draw outside in the field of view. So that will work. So you're very much invited to try it out afterwards. I don't know how we are with time.
We are good on time. We have about 5 minutes left. So if there are any further questions, go ahead.
Let me put this back in the charger so it's ready for prime time afterwards. Yes, sir.
Do you have to go there with HoloLens to define the anchor, or you can do it like from where you stand?
Sorry, I didn't understand the second part of your question.
Like,
do I have to go there to get the...
You are standing back the table and you want an anchor in the back of the room.
Yes.
Do you have to go there, or you can do it without going there?
I see. So whether I can just place my anchors here, or can I throw anchors far away, basically, is your question.
Yes.
Very cool question. So in theory, I could throw anchors here. I could throw anchors to another room if I wanted to. The problem is the point of view. So the visual data that my HoloLens that I get as I stand here, if I put, I think there was an anchor over here. So I intentionally walked around it, so it gets all the visual data around this anchor. So when she connected her HoloLens, she didn't have to look at that anchor straight. She could look just anywhere here, near here. Now, if I would place the anchor back there, there's maybe a small chance that if you stand exactly here and you see the same thing, it would work. But obviously, if I would walk now back there and try to find the anchor and I look the other side, I didn't capture that visual information. So that would be missing from them, and you'd be much more inaccurate. So currently, the way the system works is you have to be near the anchor to generate it. Yes?
With the current system, you like find out where you are based on visual cues and like depth cues. So how is it processing-wise if you'd use some other method of finding out where you are, like with, obviously GPS is not exact enough, but like a similar system where you, for example, you have a reference box where you find out where you are relative to that box, not through visual cues, but I don't know, some other signal.
So you're mentioning how we can detect these anchors. Currently, it's visual. Depth is another thing we could use because HoloLens has depth sensor. There's a bit more smart stuff we're also doing. For example, you could use Bluetooth beacons or Wi-Fi signals. And you don't have to hack. People are always scared that we hack stuff. It's not. If you turn on your phone and you switch on Wi-Fi, you have this list of Wi-Fi signals that are available. All these anchors, what we could do is we attach that information to these anchors. Right now, they're all going to have the same info, of course. But assume we have a larger map, more anchors over here, and then we go out there. If I don't want to try to find an anchor, we could to get it correct, like the precise location, you want to use vision and depth probably, just to be more precise. But to narrow it down, instead of having to try, 100 anchors, where am I? You can already narrow it down. Okay, these are the anchors that see this Wi-Fi that I'm currently seeing, that see these Bluetooth devices that I'm currently seeing. So it's these kind of things that will help. You can optimize the finding. To find it precise, right now I believe is computer vision and depth is one of the best ways. But you can definitely optimize so you don't have to search the whole space.
So the visual processing of, because as far as I understand it, the anchors are basically fixed by some program detecting this thing is near that with that angle and stuff. So that's not that demanding processing-wise.
So what we store for the anchors is, so this all happens on device. When I created these anchors here, it scans the environment and it processes it. Just takes in computer vision we call these feature points. Similar to our brain, just a bit dumber, as in, okay, here's an edge here, there's a corner here, just the patterns. And that takes a lot less space, obviously, than just storing all the images. So that all happens on device. I convert this to just image features, and that is what's being uploaded. So that's stored in the cloud for each anchor. Now, when she came and she turned on her HoloLens, she will look at the exact same area, more or less. Her HoloLens also converts all of this to features, and then those are being compared to the cloud features. And then if we get a match with, I don't know, I'm just saying random numbers now, like 100 out of 200 features match, then we can assume, okay, you probably found this anchor. Again, numbers are just random at this point, but I hope the concept is clear. I think we're exactly on time.
Yeah, we're exactly on time. I think you're going to stick around for a little bit, right?
I think so.
Yeah, so we'd like to thank you very much for your talk.